Welcome to our video.
Yay!
Here, for part A, we must determine the area of a region. Here we see our two equations. And those two equations, when graphed, form a graph that looks like this. We will be finding the area of the shaded blue part. Okay, to start we have this template of an equation where you have your your integral f of x dx. So we're just going to stop and take a moment here and say that f of x is equal to y, as seen in these equations right here. Y, we're just going to assume that they are equal. Alright, so you take the equations and you subtract them using your 4x first because of the way the graph is, it is on top. So we're going to plug that into a calculator, and we're going to find that our final answer is 256/3 units squared.
Yay! Okay, so part B is to determine a volume of some axes with a hole. So we're going to revolve the area around y equals 17. So this is what your basic volume integral is going to look like. You're going to do the big radius minus the small radius from dx. So this is what the graph's going to look like. Then there's your dx right there. So what your integral is going to look like is you're going to have your limits from 8 to 0, and then the big radius is going to be 17 squared, and then the small radius is going to be 17 minus the function, because, see, this is your big radius right here. It's from the function to 17, and then you have to take 17 minus that in order to find this part right here. So that's what you're finding there, dx. And then you plug it in, and your final answer should be that big number.
Alright, so for part C, we are going to be doing cross sections using a semicircle. So to start off, your area of a semicircle is 1/2 pi r squared, and your basic template when using cross sections is integral a to b using the area of whatever shape you are using, dx. So to start, we're just going to kind of insert some stuff in here. We've got pi over 2 on the outside because it's a constant, and then it's the integral from 0 to 8 r squared dx, where r is going to be the equations that we've been using, 4x minus x squared over 4. Therefore, when you plug all that in, it's this big mess. It looks like that. You've got your r squared from before, dx. And when you plug that into a calculator, you will find that your v is going to be 8,192 pi over 15 as your final answer.
Okay, so for part D, we have to determine k when it is the point of equal area. So this is when we have the area split exactly even. Alright, so what you have to do is you have to set up your integral, and you have your limits be from a to k, which is going to be your halfway point, and set that equal for when the area from k to b is equal to that. So when we plug that in, we're gonna use our original equations from part A, 0 to k for our limit, and then there's all that, and then set that from k to 8 because that's our upper limit, so that'll equal there. And then you plug it in your calculator.
Your wonderful CAS calculator.
Everyone loves your CAS calculator. I don't want to give it back. Don't let go of your CAS calculator. And your k is going to equal 5.222. And then there's the graph for that, but it's not drawn to scale because it looks...
So, but this point 5 is going to show when this area is going to be equal to that area.
Exactly.
And though it is not accurately depicted in this graph, you can see here the concept. That's all we're doing here.
That's all we're aiming for.
All right, so
good luck with that calculus.
Thank you for, listening to our video.
Yeah.